In this tutorial, we're going to walk you through the nesting feature in the software to achieve maximum usage of our available material. We take you through several scenarios, each demonstrating different options and which ones would work best for the type of job that you may be running. So let's just go to File, Close. So we're going to start by opening an existing file. So from the Nesting Guide project folder, we're going to open the olympicstadium.crv. Okay, so here is a sign where we have a border and all of the letters for the Olympic Stadium sign. And we've been asked to create two lots of these signs where we have one piece of material that is 48 inches by 48 inches. So how do we go about creating two copies of this using the material size that we have here? Well, the one way that we could do this is we could select all of our vectors, we could right click and we could copy them, and then in which case we could then go ahead and paste them and then manually arrange them around our sheet. Or what we could do is we could have the software do all of the hard work for us by making use of the nesting feature. So let's just drag to select all of the vectors within our job. We're going to go into the nesting tool. So the nesting tool can be found in the lower right hand corner of your drawing tab under the offset and layout tools. And if we click on that, that's going to open up the nesting tool. So this form allows us to control the different settings that we may want to apply when nesting our parts. And the software will highlight what it believes to be parts with this dark outline. So you can see the software thinks that this border is just one part, and then each one of these letters are another part. So starting at the top, we need to specify our tool and clearance settings. So first off, we need to input a tool diameter. So this needs to be the tool that you're going to use to cut these shapes out with. So in this case, we're going to put in there 1/4 of an inch as I plan to use a 1/4 inch tool. And this will leave a minimum of 1/4 inch between any parts that are cut. So then we have clearance. Now you may want to have a bigger gap between the parts to preserve any cutting finishes that we apply when we come to do the toolpaths, that being either climb or conventional milling. And so if two parts were only 1/4 inch apart, which is the same as the diameter of our tool in our case, when the tool will be cutting out one of the parts, it will also be cutting what would be the finish of another part. And so we may want to add in an additional clearance as to not touch the finish of another part. We may just want additional clearance to add tabs to hold our part in place. And so we can specify an additional clearance onto the tool diameter. So here we'll put in a clearance of 0.35 in there. So that's 0.1 bigger than our tool. And that way we're going to have a maximum of 0.6 between parts that we are cutting. And so this would mean that the minimum gap between any toolpaths that the tools may take will be a minimum gap of 0.1 in between each of the paths. So this would mean that the minimum gap between any toolpaths that the tools may take, there'll be a minimum gap of 0.1 in between each of the paths, and that will be built upon two lots of 1/4 inch cutouts. So imagine we're cutting on the outside of the O using 1/4 inch and on the outside of the L using 1/4 inch. The gap between each cutout or edge of the tool will be at 0.1, which will then build up the 0.6 inch minimum clearance between the letters. So the last option we have available in the tool and clearance settings is the border gap. And this is the margin that we can apply around the edge of our material, which helps with our hold down method not being interrupted. For example, we may want to clamp the material down or screw the material down into our spoil board. And so we could apply that border there. So in this case, we're going to look at putting in a border gap of 0.5 as I plan to screw my material into our spoil board. Right, next section we have is part nesting options, and this is where we have different methods that we can use to arrange the vectors that we've got selected to best fit the space that we have to efficiently make use of the material that we have. So for now, we're not going to select any of these options, and we'll just see how the software nests the parts using the options below. So we're just going to uncheck rotate parts. However, we are going to keep this option checked, and this will just ensure that it doesn't create a safe copy of the original design, or in some cases you may want to keep a safe copy, and we'll look at an example of that later. So moving on to the sheet options, so we're looking at how we're going to nest this, so where we're nesting from and the direction. So nesting from is where we specify a corner in our job where the software will nest from. At the moment it will nest from the bottom left hand corner, and then you can specify the nest direction, whether that's along the x-axis or along the y-axis. So we're going to set that so it's nesting from the lower left hand corner, where we're going to nest along the x-axis. Next up we have the nest boundary. So this is where we can select a layer to set our nesting boundary to, and we'll take a look at an example of this later on in this video. And we need to specify how many copies that we want to create. So we can type in a value in this field here, or we could use the arrow keys to have the software create those numbers for us. In this case, we'd like to set that to 2 copies. And then if we press apply, you'll see that we're seeing the number 2 within our 2D view, and it's the software's way of telling us that we're going to create 2 of each one of these parts. Moving on down, we have the active sheet. Okay, so the active sheet is the current sheet that we're currently working with, which is sheet 1. We only have 1 sheet in this session. If you had more, you can switch between the sheets using this drop down, and we'll look at that later on. And then nesting sheets, we're going to nest on the active sheet, and we can customize that to nest onto other sheets in your job if you had them. And again, we'll look at that later on in this tutorial. So then we simply just press the preview option to preview all of our parts. Now, from an initial look at the parts, not too bad. However, if I zoom out, I can see that I have 2 sheets here, and we can see that we have letters on here that couldn't quite fit onto this first sheet, and so have been overspilt and been added onto a brand new sheet that the software has created. And we can switch between sheets by double clicking on the actual sheet itself. So you can see we're on sheet 3 there, and if we double clicked on sheet 2, that'll take us back into sheet 2 as our default sheet. And so looking at the parts, we can see that the center of these signs is essentially going to be waste material. So why don't we look at reusing that for creating more parts, so that we can use the internal space of the sign borders to input the overspilt letters into them, just saving us eating into another sheet. So let's just reset that preview. We're just going to use this option here to zoom active view to our drawing limits. And then we're going to come over into the nesting form, and we're going to check this option here to allow parts inside of other parts. And so what the software will do is it's detecting that this area is going to be waste material, and that's indicated by this brown coloured outline. And so the software will make use of this space to fill that with what objects that it can. So now if we go ahead and preview that, you can see that we have all of the letters within our single sheet. So we're really maximising the space that we have by putting these letters onto the waste material that's inside of the sign borders. And so we also have a lot of space for other jobs too. So from the same customer, I have another job that needs cutting out. So let's see if I can combine that with this job to really make use of my material. So we're just going to reset the preview and we're just going to cancel out of the nesting form. And if you go to our layers bar at the top, you'll see we have another layer here called fast food. And if we switch that on, I'm just going to double click on the page to select the vectors on that layer. Then we're going to select it and I'm just going to nudge it up ever so slightly, just so it's not overlapping the Olympic word. And so you can see we've got this fast food word here. So we're going to try and nest all of these onto this one sheet. So let's just select all of those vectors there and then we'll go into the nesting tool. Okay, so we're just going to go with the exact same settings. We're just going to put in the number of copies here. We're going to make that 2 and we're just going to press apply there so we can see that the 2 has been updated here for the fast food. And then we're simply going to use the preview option here. And there we can see that all of the vectors for the 2 jobs are now on the same sheet. And this will really make this job more profitable as we're maximising the use of the material that we've purchased to create this job. So now what we could do is we could look at applying a quick profile toolpath around these vectors, and then we can demonstrate the tool diameter and the clearance gap between each of the parts for a better visualization of the tool and clearance settings. So let's just go ahead there and then just press OK, and we're going to switch over to the toolpaths tab. So we'll quickly glance over our material setup, so 1/2 inch thick, lower left, XY datum position, Z0 on the material surface, and you want to ensure that all of your rapid Z gaps and your home start position are all safe and appropriate for your particular machine, the projects you're cutting and the tools that you are using. Okay, so I'm going to select all of these vectors and we're just going to apply a profile toolpath here. So we're going to cut all the way through the material, so Z equals, use this select option here, and we're going to select that 1/4 inch tool, press select, and we're going to machine those vectors on the outside. We can simply go ahead there and press calculate and we can preview that toolpath. If we wanted to, we could go ahead and delete the waste material to get a better idea of what our part or our parts would look like. And so what I want to show you here is the gap between the toolpaths and the clearance that's available while cutting, to show you that they're not going to be too close. And we can view this much better in the 2D view. So if we go into the 2D view, and if we just switch on the visibility of our toolpath, we can currently see the wireframe representation. And if we come up into our view toolbar here, we can click on to the drawing style where we can toggle from wireframe to a solid view. And the solid view basically gives us a representation of the tool's cutout. And so if we just kind of just zoom in over here, let's take a look at the D and the A, for example. And so here we can see that where we cut with the 1/4 inch tool, we actually have a gap in between each cutout, which is a minimum gap of 0.1, which we could use for tabs or just keep it out of the way of it affecting the finished areas of the other parts. So we're now going to look at another example of nesting. So we'll just close out of the toolpaths form and we're just going to go to File, Close. I'm not going to save that. And then we're going to go in and we're going to open an existing file. So here we're going to look at the nesting example. We're going to open that. Okay, so we've got a sheet set up here that's 48 by 48 inches, and we've got a set of vectors over on the right hand side of our job, and we want to create 25 copies of each of these vectors to put onto our sheet. So we're going to look at just taking these part for now. I want to create 25 copies. So with those vectors selected, let's go into the nesting tool. We're going to use the same tool and clearance settings as before. I'm just going to uncheck the option to allow parts inside other parts, and then here we can input a number of copies, so it's remembered the values that I've used previously. So you can see 25 is in there, you can see 25 is also on this part here, so we're just going to keep that as it is, but if you wanted to change that, you just simply change it to the number of copies that you want to use. And we're going to go ahead there and then press apply, and then we can simply preview that. So here we can see where the parts have been nested along the x-axis, so you can see all of those there. And we can also see that we may have areas that have been overspilt, and so we can see we've got 5 copies of our parts that have been overspilt onto sheet 3 because they couldn't fit onto our sheet. So we're going to look at resetting this preview, and then we're just going to zoom our active view to the drawing limits here. And then we'll look at how we can demonstrate another way that we can try to nest these vectors, or try to do so in a way that we can nest them all onto one sheet. And so we're going to look at using the mirror parts to find best fit. And so we'd use this if we weren't too concerned with which side of the part is the top side, as some materials have a finished side and an unfinished side, so you'd have to bear that in mind if you wanted to mirror the parts to best fit the material. So we're going to check that option here, and then again we're going to go with 25 copies. We're going to preview that. And we can see that we do have an overspill here. We have 2 parts on sheet 3. And so what's happened here is the parts have been nested along the x-axis. And where it's got to the end here, the software can no longer create a new row, and therefore it will try to mirror parts to fit in the space. And that's what it's done to these 3 parts over here. So we're going to look at another option to see if we can better fit our parts in the material. So we're just going to uncheck this option to mirror parts to find best fit. And then we're going to look at this option here to rotate parts to find best fit. And so what the software will do is it will rotate the vectors in increments of whatever angle you put in this field here to best fit the parts within your space. So we're going to check that option, and we're going to go with a rotation step angle of 45 degrees. Now, you may need to think about the importance of the direction of the grain when doing this, because if you wanted all of your parts to have the same grain direction, it's probably not a good idea to have the rotation option selected. In this case, I'm not too concerned, so we're going to keep that at 45 degrees here. And then we could just simply go ahead and preview our part, and here you can see that some of our parts are actually rotated in increments of 45 degrees. However, we can still see that 2 of the parts aren't quite fitting on to our sheet that we want to nest all of our parts onto. So let's see again how we can alter the settings to get all of the parts onto one sheet. So what we can do is we can look at reducing the rotational step angle if we wasn't concerned with the grain direction of the material, to see if we can really maximise the material usage. If the grain direction is not a concern, then we can look at lowering this rotational number to as low as 1 degree increments, so it can rotate each of these vectors 360 times using the 1 degree step angle to find the best fit for our sheet. So here we could just input 1 degree in there, and then we could go ahead and we can preview that. And so there we have all 25 copies now on one sheet. So there we've demonstrated various ways of really maximising the space that we have available to use. So we're just going to reset this preview, and we're just going to look at another example. So we'll cancel out here. Now let's imagine that we only had this size material available for us to use. And for our next job, we want to take these vectors and we want to create 5 copies of each one of these parts. So as always, to maximise the material, we should make use of the nesting feature. So we're going to go into the nesting tool. We're going to go the exact same settings as before, except this time we're going to put in a number of copies there as 5, and we can simply press apply. And then we can simply go ahead there and then preview that. And so here we can see that the software has nested these successfully. It's rotated quite a lot of the parts to best fit into our space, where it's nested them along the x-axis, and we can see how everything is laid out and is fitting within our sheet there. Now, let's imagine that we've already ran this job on the machine, and now what we want to do is we want to make use of the remaining space that we have here so that we can nest further objects into this particular space that's available to us on the right-hand side. So we're just going to OK that, and then we're going to go into Create Vectors, where we're going to draw in a rectangle. So I'm just going to snap to the bottom right hand corner here. We're just going to pull this out over here, somewhere like that. So we've got this vector rectangle that kind of represents all of that empty space there. And then we're just going to right click on that vector, and we're going to say to move to layer, new layer, and we're going to call this one boundary, and then we can just OK that. And so now what we can do is we can then take these three parts, and then we can go into the nesting tool. We're going to use the same settings, except we just want to create 5 copies of these new vectors. So we're just going to put in 5 in there. We'll press apply just to accept that. But we're going to make use of the bounds layer. So we've just created that vector that represents the area or the space that we've got left from the previous job, where we moved that vector onto the boundary layer. We're going to use the bounds layer here, and here you can select the layer, in which case we're choosing the boundary layer, and then we can simply go ahead and then press preview, and there you can see that the software has managed to nest all of those parts within our boundary layer, where that vector basically represents the space that we have, and so it's managed to nest along the x-axis within that vector. And so it just really demonstrates how we can plan ahead with the jobs that we are given to really maximise the usage out of every piece of material that we use, resulting in more profits in the long run. So let's just cancel out here. We're just going to close out of this example. We're going to look at another example. So we're going to open an existing file, and here we're going to look at the widget vector example. And if we open that up, we can take a look at what we have. So we've got the Vectric widget here, and the part has been set up in such a way where all of our toolpaths are actually associated with layers. So if we take a look at our layers, we have the outline shape, we've got recessed rectangles, we've got text, and we've got drill holes. And so using the automatic vector selection option, we can associate specific rules to the toolpath. So for example, let's just go into one of the toolpaths. So we'll go into the drill holes toolpath here. So at the bottom, we have the vector selection option. It's currently set to automatic. And so this is where the software is automatically selecting the vectors rather than us manually selecting which vectors the software needs to use to create this toolpath. And it's done that on an automatic basis. And if we go into the selector, it does that based on various rules and filters that we've specified for this particular toolpath. So for example, we've said to the software that we only want it to pull out all the circles that are on the drill holes layer. Well, we want to associate that with this particular toolpath. And there are other tutorials that cover the setup for the automatic vector selection in more detail, and you can find those in the related videos section for this tutorial. So each one of these toolpaths is associated to vectors on a particular layer, and I could cut this one on its own as a prototype. So let's take a look at the preview. So we'll just preview all the toolpaths here, and we can see that that is what our Vectric widget prototype would look like. And so having the part set up this way, where we let the software pick the vectors for us by applying various rules, means that if at some point in the future where I may want to mass produce this part, I can simply nest the vectors we have here using the nesting feature. And because the toolpaths are associated with vectors on particular layers, all I have to do is simply recalculate the toolpath without having to manually add in the copies of nested vectors to each toolpath. The software will automatically do that for me. So let's have a look at how to do this. So if we just close out here, I'm just going to switch over to our drawing tab. We'll go into the 2D view here, and then we're going to use the set job dimensions and origin. Okay, so here we're going to change this from 9 by 9 to 36 by 36 in this instance. And then we can simply go ahead there and then press OK. So we're going to select all of the vectors here and we're going to go into the nesting tool. Okay, so working our way down the form, we're going to use a tool diameter of 1/4 inch. We're going to have a clearance of 0.3 in this example and a border gap of 1/4 inch. We're going to rotate the parts to find the best fit, so we'll put that at 90 degrees, where we're going to then nest from the lower left-hand corner along the x-axis. We're not going to use a nest boundary, so we're going to uncheck that option there. And then we need to specify how many copies we want. In this case, we want 18 copies here. And then we simply press apply and we can see it's applied that there, and then we can simply go ahead and preview that, and we can see straight away that we have an overspill, and we can see that one part has been spilt over onto sheet 3. So let's see if we can look at changing any of the options here to better fit all of the parts onto one sheet. So we'll just look at rotating the parts. So we're just going to reduce that to step angle to, let's say, 30 degrees in this case. And what we should do is we should just reset that preview and then put it to 30, press apply, and then we'll go ahead and we'll preview that. And here we can see that all 18 of our parts have been nested onto our sheet. And so we can basically OK that to come out of the form. And then what we can do is we can switch over to the Toolpaths tab, and all we need to do is use this option here to recalculate all of our toolpaths, and the software has successfully recalculated all of those toolpaths there, so we can just simply go ahead and press OK. Now we have all of the toolpaths assigned to all of the copies of the vectors that we've created. And so now we have 18 individual widgets to cut on our large piece of material, with thanks to the automatic vector selection option that was applied to each of the toolpaths, along with the ability to nest all 18 parts. And so if we go into our toolpath preview, and we can just preview all of these toolpaths just to take a look at all of those parts. So now we're going to look at an example where we can nest two-sided parts if you're working in a double-sided job. So let's just go to File, Close, and then we're going to go and open an existing file. We're going to look at the two-sided example. So we'll open that up. So here we have a part that is set up in a two-sided environment. So we've got an outline of our part, we've got a series of circles that represent drill holes, and if we switch to the bottom side, we can see we have two vectors here that represent dados. And if we switch back to the top side, we could look at how we can nest two-sided parts here. So if we go into the nesting tool, you'll see we have this option to nest two-sided parts, and that's automatically checked because the software recognises that we are in a two-sided environment. And so what it will do is it will nest both the top and bottom parts within a selection. So for example, if we select these vectors here, you'll see that the software has recognised the part as the overall outline of the top and bottom vectors combined. So you can see where the dados are coming over here and over here, and we can actually see the representation of the vectors on the other side represented by this aqua line. So the aqua shapes represent parts that are on the other side. And so generally as a part, it's highlighted everything that's on both the top and the bottom. And then we could just look at using the settings that we've used before. And then here we could go and have a look at various number of copies. So let's say, for example, we wanted 8 in here or 9. Let's just put that in there. So let's go with 8, and then we'll just simply press apply. You can see it's highlighted that there's 8 parts going to be created there, and then we can preview that and we can see those parts have been nested. And we can also see, because we are in a multi-sided view here, we can see the vectors on the other side, and we can see that those have been nested also. And if we switch over to the bottom, we can see all of those dados that have been nested on the bottom side in line with the parts that were on the top side. So let's just OK that. Now we're going to look at a final example. So we're just going to go to File, Close, and then we're going to go and open an existing file from the project folder. We're going to look at the multi-material buttons example. Now we're going to look at one final option, and that's nesting parts across various sheets. If, for example, you were creating projects that are formed from multiple materials. So here we have a file that was set up to machine a series of buttons using different materials that we would inlay into various parts to create the finished button project. And so you can see that I have several sheets already set up in my job. You can see we have our layout sheet. So this is just where I've just roughly drew up the design for the button. We have a piece of cherry, we have plywood, we have a piece of scrap acrylic that I've used on a previous job, but I still have this extra space that I could make use of. And then I've got a new piece of acrylic here. And so to access our sheets, we can come over to the Sheets tab over on the left hand side here. And so here we can see all of those sheets, and we can also see the different dimensions that we have for each one of those sheets as well. Okay, so the idea is that we would like the outer border of the button to be cut in plywood. We'd like the inner part of the button to be in a cherry, and we want each one of these buttonholes to be machined in a mirrored acrylic. And so ultimately we'll be looking to create a set of buttons that's made up from all of these contrasting materials. So we're going to have a look at how we can do that. So we're going to go into the Drawing tab, and we're going to go into the Nesting tool. So here we need to select the vectors that we want to nest. So as I said, I want the border part of our button to be machined in plywood. So I'm going to take both of those vectors there. You can see that the software is recognising this whole selection as one part there. And then we can come over to our tool and clearance settings. So we're going to go with a tool diameter of 1/8 of an inch, clearance 0.1, border gap 0.1, and then we want to ensure that we uncheck the remove original parts, as I'd like to keep a safe copy of my layout design here on our layout sheet. And what it will do is it will just nest the parts that we want to the sheet that we specify, but it will still keep our layout vectors in place, and so it won't interfere with anything that we see here. Okay, so we're going to nest from the lower left along the X direction, and then we want to create 8 copies here, so we're going to put 8 in there. Okay, and then what we want to do is we want to go to the customize option, because we want to use a different sheet. If we use active sheet at the moment, it's going to use the layout sheet, which we can see is the active sheet here. In this case, we actually want to nest all of those border parts to this plywood sheet here. And so to do that, we're going to use the customize option. And so here you'll see that the software has now opened up a custom sheet selection dialog box where we can then specify the sheets that we want to use for nesting. So in this case, we just use the drop down option here, and that will display all of the sheets that we have in our job, in which case I would like to use the plywood sheet. And then we can specify the quantity. So if we double left mouse click on the no limit, you'll see we have two options. We have the option to apply one or no limit. So no limit is exactly as we've been working throughout this video, whereby if you specified the number of copies and that number of copies couldn't fit on your sheet, then the software would automatically create a new sheet for you, and it will input those overspilt vectors or those copies onto that new sheet. The other option is by specifying one, where we tell the software, I just want to use this sheet only and I don't want to overspill onto another sheet. And then you can use the one option. We're going to look shortly at how we can use the one option but then still have a set of overspill sheets that we select rather than the software create those extra sheets for us. And we're going to look at that in a moment. So in this case, I'm not too concerned if we have more copies that get overspilt onto an automatically created new sheet that's been created by the software. So I'm going to use the no limit option here. And then we could simply go ahead there and then press OK. Okay, so we've got the number of copies as 8, so we're going to apply that. We can see the number 8 has been visible there, so we know we're going to be creating 8 copies. And then once we go ahead and press preview, you'll see that the software has created 1, 2, 3, 4, 5, 6, 7, 8 copies onto our plywood sheet. And we still have access to the original design within our layout sheet there. And so the idea is we're going to profile the outside of all of these circle vectors, and we're going to pocket the inside of those vectors, whereby then what we can do is we can create another part that just uses the inner circle here. We're going to look at cutting that out of a cherry, and that cherry will slot into the pockets within the plywood, so we're creating the contrasting project there. Okay, so we're just going to then go on to our next part. So if we go back into the layout, okay, so just double click in there, and then what we're going to do is we're going to take these vectors here, so the inner border along with the 4 holes, the buttonholes vectors, and we want to machine this out of a cherry material where we're going to cut along the outside and inside of those buttonholes. So again, we're just going to go with those same settings from the lower left along X. Number of copies here, we want 8 of those, so we're just going to press apply. We can see that number 8 has been added there. Active sheet is currently the layout. Now we actually want to change that, so we're going to go to the nesting sheets where we can customize that. So we're going to change that from plywood to the cherry, and again we'll just set that to no limit, and then we can simply go ahead there and press OK, and then we can preview that, and we can see we've got 1, 2, 3, 4, 5, 6, 7, 8 parts on our cherry material. So now we want to look at creating the buttonholes. So the buttonholes will slot into the profile holes of the cherry, where that cherry piece will slot into the pocket of the plywood. And so I'd like to cut these buttonholes out of my acrylic material. And you can see if we double click on the scrap acrylic, I've got this space left over from a job that I've previously worked on. And I want to really just utilise this just so that we don't waste any material. So we're just going to cancel out of this form here. We're going to go and draw in a rectangle. So like we did before, we're just creating a vector boundary in order for us to tell the software where's available for us to use. So we're just going to close out there, and I'm just going to tweak this rectangle ever so slightly. So we'll put that over there and over to the left. So really just maximising that space there. And so what we can do then is we can then use that vector as a boundary. So what we need to do is we need to right click and move that to a layer. So we're going to move to a layer, new layer, in which case we're going to call this one boundary. And then we can simply go ahead and press OK. Okay then, so if we go into our layout sheet here, and then if we just take those vectors, we're going to go into the nesting tool, and we're going to go with the same settings that we did before. We're going to have 8 copies. And so what we want to do is we want to specify that we're going on to the scrap acrylic sheet here. So if we go to customize here, we're going to say scrap acrylic, and then we could go ahead and press OK. And we must remember to use our bounds layer, that boundary vector, in order for us to just fill out that space. So we're going to say use bounds layer, and it's pulled out the boundary layer there. And we can simply go ahead and then press preview. Okay, so it's managed to nest the majority of those buttonholes onto our scrap piece of acrylic. However, we can see that the software has automatically created another version of our scrap acrylic sheet and has positioned the excess buttonholes over here. Now, we don't want this automatically created scrap acrylic sheet here, as I've already got an acrylic sheet in my job. It's another piece of material that I've got knocking around in the workshop, and I'd like that overspill to go onto this sheet here. Okay, so what we can do is if we just reset that preview, and then we can go into customize, we're going to say, yeah, we want our parts to be nested onto the scrap acrylic, but what we want to do is we want to set that so that we can only fit as much as we can within this space. And then for any overspill vectors, we're going to use this plus icon to add a new sheet to our list, where we're going to select the acrylic option. And so we're telling the software we want you to fill as much as we can on the scrap acrylic sheet, and then anything that overspills, could you please put that onto the acrylic sheet. And we'll just set the acrylic sheet to no limit, and then if we just so happen to overspill our acrylic sheet, it will just create a brand new sheet that matches the acrylic sheet, just as we've done in previous examples. Okay, and so we're going to use that option there. Now, if you wanted to change the order that the sheets are nested to, you can simply select one of them and then use the down arrow keys if you wanted. And if you wanted to delete a sheet, you could use this option here, and that will just remove that sheet from the list. In this case, we're happy to go with the setup we've got here, so we'll just go ahead and press OK. And then we can simply preview that and we can take a look. So we've got the parts, the buttonholes on our scrap acrylic, and if we move over, we can see those excess buttonholes have been added to our acrylic sheet over here. And so there we have all of our parts ready to machine, and then we can create and assemble our multi-material button. And we also still have access to our original design should we want to edit that, alter it, make more copies in the future. So that really concludes this tutorial, where we've looked at lots of different options to use within the nesting form. For version 11.55, we've introduced a new option in the nesting form that allows you to fill your sheet with a given part. This is useful for scenarios where you just want to fill your sheet with parts but don't quite know exactly how many will fit, and so the software calculates that so you don't have to. Simply mark the part as filler in the form, and the software will identify the filler part with a green star in the 2D view. Hit the preview and see the results. You can also combine filler parts to other nested items. For example, let's say you wanted to nest 20 of one part and then fill the remaining space with the filler part, you can do just that. So first you want to select the part that you'd like to nest. So for example, we'll take this widget here and we'll say that we want 20 copies in there, hit apply, and then we'll preview that. And we can see that our job has been filled with 20 parts, and we've got all of this space left on our sheet that we could essentially use up with other items that we could just fill that space with. So to do that, we'll just reset our preview, and then we could click on a filler part. For example, we could take this item here and we could say, actually, I want that to be a filler item. Press apply. You'll see that green star there represents that's a filler part. And then if we go ahead and press shift just to select our original part that we wanted to nest, and then go ahead and press preview, we should see the 20 parts plus all of the other parts that have just been filled into that space. You also have the ability to have multiple filler parts where the software will fill what it can in order of size, where it will fill and prioritise the larger items followed by the smaller items. So for example, if we go ahead and reset this preview, let's say we wanted to also include this part here as part of our nesting. We could just click out to deselect all of the parts, select this part here, let's mark that as filler, press apply. You can see it's marked as filler with that green star there. And if we go ahead and shift our original nested part of 20, and then our other filler part here, again marked with that green star, and then if we go ahead and press preview, what we would see is the software will nest our 20 widget parts, but then it's noticed or it's identified that there is a larger part here, and it's going to try and fill as many of the larger item as it can within the sheet, and then where there's any space left, it's going to fill in those smaller areas with that smaller part that we had within that filler selection. So this will help you further maximise your material and minimise your waste.